Hi students, in the previous video we see to find a Cartesian product, and suppose if the Cartesian product is given, how to find the sets. Okay, in the previous video we find the Cartesian product of any two sets, and if the Cartesian product is given, how to find the individual sets. Now in this video we see the remaining problems. In the remaining problems involving the sets of union, intersection and difference. You know very well in the 9th standard how to find the union of two sets. Okay, the union symbol you know very well is a U, and how to find the intersection of any two sets. How to find the intersection of any two sets? The common element in both the sets is called intersection. And next one is a difference of two sets. Now in this video we see the sum of this exercise involving union, intersection and difference, and also involving the Cartesian product. So we see the sum of all category, that is union, intersection, difference and also Cartesian product. For example, I will take a two set. The first one is a set A. Suppose it contains some elements 1, 2, 3 and 4, and I will take one more set. The set name is B. Suppose it contains some elements. The elements are 2, 4, 6, 8 and 10. For example, I will take a two sets. The first set A contains 4 elements 1, 2, 3, 4, and another one is B. It contains some 5 elements 2, 4, 6, 8 and 10. You know the symbol of union is U symbol. How to read? It should be read as A union B. What is the working rule to find the union of any two sets? In union we write all the elements contained in both A and B, but repetition of the element is not occur. Okay, we write in ascending order. We see what is the least number in both the sets A and B. The least number is 1. So first we write 1, and the next number is 2. You see the number 2 is lies both in A and B. A repetition is not allowed, so we write only 1, 2. The next number is 3, and also you see 4 lies twice, so you write only once, 4. So all the elements is over in A, but in B some more elements is there. What are the remaining elements in B? The elements are 6, 8 and 10. So 6, 8 and 10. So it is the value of A union B, that is the union of any two sets. So union means we mingled all the elements. Suppose a element is lies both the sets, you write only once. So it is the working rule to find the union of any two sets. Now we come to intersection. So intersection of a sets. I will take the two same sets. The sets are A and B. You know the symbol of an intersection A, and it is the symbol of intersection. How should we read? It is A intersection B. You know the working rule, the name intersection means a common. So we write the elements which is common in both A and B. Now we come in A and B. What are the elements is common in A and B? The element 2 is common, and one more element 4 is common. Now you see the first element A is 1, but the element 1 is not occur in B. The second element of A is 2, the same element is also occur in B, so we write this. So the first element of A intersection B is 2, and the next one is 4. So our intersection means a common. So common element in the given two sets. It is a symbol of intersection. Okay, so A intersection B value is just 2 comma 4. What is the reason the number 3 is not occur in A intersection B? Because the number 3 lies in A but not lies in B, and also the number 6 lies in B but is not lies in A, so you leave the element 6. In the same manner we leave 8 and 10. So it is a working rule to find the intersection of any two sets. And the third one is a difference of a set. Now to find the difference of any two sets. So first set is A. Okay, it is a symbol of a difference. The second set is B. How to find the difference of these two sets? For understanding, I write elaborate. We write the values of the set A. What is the values of the set A? The set A contains 1, 2, 3 and 4. And also the values of B. The values or the elements of B is 2, 4, 6, 8 and 10. For your easy convenient, inside we write the sets values of A and B. When we find the difference, first we strike out the common elements. So what are the common elements in A and B we see? You see, first of all the number 2 is there. We strike out. And what is the next number is common in both A and B? The next number is 4. I strike out. In A difference B, what is the first set is occur? It is A. So A difference B means all the elements should lies in A, but the element is does not lies in B. So we strike out the common elements. So what is the values of A difference B? So the remaining elements of A. So what are the remaining elements of A? 1, 3. So 1 comma 3 is a working rule to find the difference of any two sets. Is a value of A difference B. Suppose to find the difference of B and A. Now you tell what is the answer of a B difference A. So B difference A means all the elements in B, but the element is does not occur in A. So what is the value of B difference A? We strike out the common element. What is the first set? B. So we write the remaining elements of B. What are the remaining elements of B? The remaining elements of B is 6, 8 and 10. So it is a working rule to find the difference of any two sets. The side work for our understanding. If you know very well, you don't write the side work. But if you put the side work, there is no mistake to your problems. So the difference of any two sets, in side work, we first of all strike out the common elements, and A difference B means we check what is the first set. The first set is A. So all the elements should be lies in A, but the element is does not lies in B. So that's why we strike out the common elements. So it's the value of A difference B. Suppose the reverse will be X. Suppose to find the B difference A, the same working rule. In B difference A sets elements, all the elements lies in B, but the element is does not lies in A. So we strike out the common elements. So the remaining elements of B, the remaining elements of B is 6, 8, 10. So B difference A has 3 elements, 6, 8 and 10. Here the value of the sets A is 5, 6. The set B is 4, 5, 6, and the set C is 5, 6, 7. So there will be 3 sets there. Then to show the value of A cross A, that is the Cartesian product of A cross A, it should be is equal to B cross B intersection of C cross C. Now to prove LHS and RHS both are is equal. So the solution given, first we write the 3 sets. Now to prove A cross A is equal to B cross B intersection of C cross C. In our proof sum always we will be take first of all the left hand side. So left hand side, that is LHS. What is the value of LHS is A cross A. So first we find A cross A. So A cross A. The set A is given. The value of the set A is 5, 6. Cross. Again, what is the next set? A. So again we write the values of A. The values of A is again 5 comma 6. Now to find the Cartesian product of these two sets. In the previous video we will be see elaborate how to find the Cartesian product of any two sets. That is to write all possible ordered pairs. In ordered pair, the first element always lies in the first set. The second element lies in the second set. So what is the first possible ordered pair? Is 5 comma 5. Do you identify how to come 5 comma 5? The element 5 is lies in the first element in the first set, and one more 5 lies in the second set first element. So it is the first possible ordered pair 5 comma 5. So what is the possible of another ordered pair? Is 5 comma 6. So 5 comma 6. That is the element 5 lies in the first set and the element 6 lies in the second set. So the another possible order is, so 5. The next set number of first set is 6. So 6 comma 5. And one more possible ordered pair is there. The values are is 6 comma 6. So to write all possible ordered pair, I recall again 5 comma 5, then 5 comma 6, then we move 6 comma 5 and 6 comma 6. So it is a value of A cross A. We put it is equation 1. Now we check the same ordered pair will come the RHS also. What is the RHS? That is the right hand side. The right hand side is B cross B intersection of C cross C. So to find the intersection of these two Cartesian product. So in B cross B intersection of C cross C, first we find the Cartesian product of B cross B. Next to find the Cartesian product of C cross C, because we need intersection of these two sets. If we find the intersection, first we need two sets. So first we find the Cartesian product of B cross B and Cartesian product of C cross C. So in RHS what we first find? The Cartesian product of B cross B. B cross B intersection of C cross C. So first we find B cross B. So these are the elements of B, 4 comma 5 comma 6. Cross, again we need 5, so 4 comma 5 comma 6. So first we find the Cartesian product of these two sets. The ordered pair, the first possible ordered pair is 4 comma 4. Next one is 4 comma 5. Next 4 comma 6. That is in the first set first number you don't change, 4 comma 4 and 4 comma 5, 4 comma 6. You don't change the first set first element, we change the elements in the second set. We do the work of all elements in the first set. Now first element over. Next, what is the next element of the first set is 5. So we will be take 5. 5 comma the second set first element. The second set first element is 4. Next element, this 5 comma 5. Next 5 comma 6. Next possible order pairs are, the next number of 5 is 6. We do the same work. So we write it is 6 comma 4. So 6 comma 4. Next 6 comma 5. This 6 comma 5. And the last possible order pair is 6 comma 6. So it is the value of B cross B. Next we find the Cartesian product of C cross C. So C cross C. What are the elements in C? The elements in C are 5, 6, 7. Cross. Again what is the set? C. So you do the same work. 5, 6, 7. Now to find the Cartesian product of these two sets, same way What is the first possible order pair? That is 5 comma 5. How to come 5 comma 5? The first element in the first set is 5. The first element in the second set is also 5. So we write 5 comma 5. The next possible order pair is 5 comma 6. That is a 5 comma 6. The next one is 5 comma 7. So don't change the first number and we move the next number to the second set. We do the same work in the second number and third number. What is the second number in the first set? Is 6. So 6 comma 5. Next number is a 6 comma 6. And the next number is 6 comma 7. Then we moving the next number. What is the next number? Is a 7. So 7 comma 5. 7 comma 5. And 7 comma 6. The last number is 7 comma 7. So you don't leave any one of the ordered pair. We must write all possible ordered pair. So it is a C cross C values. Now to find B cross B intersection of a C cross C. We already say what is meant by an intersection. Intersection means a common element in B cross B and C cross C. Now we check. It is a value of a B cross B and it is a value of a C cross C. So I take the common ordered pair. First we see 4 comma 4 lies in B cross B, but the ordered pair 4 comma 4 does not lies in ordered pair C comma C. So the ordered pair 4 comma 4 will not come here. So what is the ordered pair common in both B cross B and C cross C? You see 4 comma 4 is not there. 4 comma 4, 4 comma 5, 4 comma 6, this all the number involving first number is a 4. In the C cross C, all the number is starting from 5. So 4 comma starting the number of 4 is not occur here. So we check what is the common elements. You see 5 comma 5 is a common. I take the common ordered pair 5 comma 5. So 5 comma 5 is common in both the sets. You identify what is the next common ordered pair? You identify anyone? Yes, the next one is 5 comma 6. 5 comma 6 is common in both the cross product. Anyone is common? Anyone is common in the two sets? We say 6 comma 5. This 6 comma 5 is common. One ordered pair is remaining, is also common in both the sets. You identify? Which one is common in both? That is 6 comma 6. So I take there will be a 4 ordered pair. This 4 ordered pair only common in both the sets. You see the remaining is not common in both. For example, I will be take 5 comma 4. The ordered pair 5 comma 4 lies in B cross B. We check C cross C, 5 comma 4 is there? No. No ordered pair is involving 5 comma 4. So that's why we leave 5 comma 4. And 6 comma 4 is lies in B cross B. The ordered pair 6 comma 4 is not lies in C cross C, so we leave. So intersection means a common. So these 4 ordered pair only common in both the sets. So we write B cross B intersection of C cross C. So the common elements in both the sets. So first one is 5 comma 5. Next one is 5 comma 6. Next 6 comma 5. And last is 6 comma 6. I put it is the second equation. Now we check from 1 and 2. In 1 and 2, both are involving common elements. In 1 also we see there will be a 4 ordered pair. It also start from say 5 comma 5, 5 comma 6, 6 comma 5, 6 comma 6. So both LHS and RHS both have the equal number of ordered pair and also same number will come. So from 1 and 2 we conclude LHS and RHS both are equal. Therefore, the Cartesian product of A and A, that is A cross A, it should be is equal to B cross B intersection C cross C. From 1 and 2, LHS is equal to RHS. LHS and RHS both are involving the same number of ordered pair, that is 5, 5, 5, 6, 6, 5 and 6, 6. So we come to the conclusion LHS and RHS both have the equal number of same ordered pair. Therefore, A cross A, that is the Cartesian product of A and A, it should be is equal to Cartesian product of B intersection of Cartesian product of C is proved. That is A cross A, it should be is equal to B cross B intersection of C cross C. All elements are same, at the same time the equal number of ordered pair. Then only we come to the conclusion both LHS and RHS both are equal. Fifth question, there will be 4 sets are there. The set A is 1, 2, 3, B 2, 3, 5, C 3, 4 and D 1, 3, 5. The question is, check if A, you should be read it as intersection. A intersection C cross B intersection D is equal to A cross B intersection of C cross D is true. It's not a proof sum. Now we check both are equal or not. Suppose both are equal, we come to the conclusion the given one is true. If it is not equal, we come to the conclusion the given one is not true or false. So there will be 4 sets A, B, C and D. So first we check the value of left hand side, that is LHS. What is LHS? A intersection C cross B intersection D. So we need the Cartesian product of these 2 sets. Okay, the individual sets are only given A, B, C and D. If we find A intersection C cross B intersection D, first we find, we identify, first we find the intersection of these sets. We don't know have the value of A intersection C and B intersection D. So the first step to find the intersection of A and C. So A intersection C. What is the working rule to find the intersection? Intersection means a common. So the common element in the given sets. So the common element in the set A and C. What is the common element in A and C? It is a set A. It contains 3 elements 1, 2, 3. And set C contains 2 elements 3, 4. So what is the element is common in both A and C? In A and C, what is the element is common? Only one element. The element is, yes, it is 3. 1, 2 is lies in A, but is not lies in C. You see, the number 3 is common in A and C, so A intersection C is 3. The number 4 is not occur in A intersection C. Why? Because the element 4 lies only in C but not in A. So the common element in A and C is only one element, the element is 3. So first we find the set A intersection C. Next we find B intersection D. So B intersection D. B intersection D means a common elements in B and D. So what are the elements is common in B and D? We see the sets first of all B and D. So it's a set B and it is a D. Do you identify which one is common in B and D? How many elements are there? There will be 2 elements. The elements are, one is 3 and another one is 5. So 3 and 5. These 2 element is only common in B and D. So 3, 5. So this is the value of B intersection D, 3, 5. Now we find A intersection C cross B intersection D. The value of A intersection C is only one element 3 cross the value of B intersection D is 3, 5. Now we write the Cartesian product of these two sets. How to write the Cartesian product of any two sets, you know very well. So what is the first possible ordered pair? What is the first possible ordered pair? The first possible ordered pair is 3, 3. How to come 3, 3? Always in the ordered pair, the first element lies in the first set, the second element lies in the second set. So 3, 3. But in the first set it contains only one element. So what is the next possible ordered pair? The next possible ordered pair is 3, 5. So it is the equation 1. Actually it is the value of the LHS. That is the value of A intersection C cross B intersection D. So it is the value of LHS. So I put it is equation 1. Now we check the same element will come in the RHS also. Suppose the RHS is also contains exactly these two ordered pair, that is 3, 3 and 3, 5. We come to the conclusion the given one is a true. Suppose the element is not occur, other than these two ordered pair, one more ordered pair will come. We come to the conclusion the given one is not true or false. Okay, now we find the value of RHS. Right hand side. What is the value of RHS? The RHS is A cross B intersection of C cross D. So A cross B intersection of C cross D. If we find the A cross B intersection C cross D, first we find the Cartesian product of A and B. Next we find the Cartesian product of C and D. What is the reason to find these two? First of all, we need an intersection. If we need an intersection, first we find the sets. Intersection is common. So the element is common in A cross B and C cross D. So the first step to find the value of A cross B. A cross B. What are the elements of A? The elements of A is given, they are 1, 2, 3. Cross, the next set is B. What are the elements of B? The elements of B is 2, 3, 5. Now to write the Cartesian product of these two sets. You know very well how to write the order pair. What is the first possible order pair? Is 1, 2. Okay, 1, 2. Don't change the first set, first element. We moving the elements of the second set. So what is the next possible order pair? Is 1, 3. The next one is 1, 5. Okay. Next one. We moving the next element of the first set. After 1, the next element is 2. So the next possible order pair is this 2, 2. So 2, 2. Then 2, 3. Then 2, 5. Next, after 2, the next element is 3. We moving. So the next possible order pair is, that is 3, 2. The next one 3, 3, and the last one is 3, 5. So it is a value of A cross B. Next we find the Cartesian product of C cross D. C cross D, the elements of C is 3, 4 cross, the element of D is 1, 3, 5. Now we write the Cartesian product of these two sets. The first possible order pair is 3, 1. Okay. The next one is 3, 3. The next 3, 5. 3, 1, 3, 3, 3, 5. Next, we moving the next element of the first set is 4. So the next possible order pair is 4, 1. 4, 1, Next one 4 comma 3, and the last one is 4 comma 5. So it is a value of C cross D. Now we find the intersection of A cross B and C cross D. A cross B intersection of C cross D. You know very well, intersection means a common. We check what are the elements is common in A cross B and C cross D. Do you identify what is the element is common? The common elements are, first of all, 1 comma 2 is lies in A cross B, but in C cross D 1 comma 2 is not there. Okay, what are the common elements is that we identify. Any one of the common element is the first element. You write any manner, any one of the ordered pair we write. 3 comma 1 is lies in C cross D. That element is also lies in A cross B, is a 3 comma 1. 3 comma 1 is not there. Next 3 comma 3 is lies in C cross D. We check in A cross B 3 comma 3 is there. 3 comma 3 is there? Yes. 3 comma 3. So first order pair is 3 comma 3. Next 3 comma 5. We check the order pair 3 comma 5 is also lies in A cross B. In A cross B 3 comma 5 is the, yes, is the lowest element, is a 3 comma 5. Next 4 comma 1, 4 comma 3, 4 comma 5. The remaining 3 ordered pair, the starting number is a 4. So you check in A cross B, no one of the ordered pair is not starting in 4 comma 4, 4 comma 3 and 4 comma 5 like this. So we need only the common elements. So in A cross B and C cross D, these 2 ordered pair only is a common, and all the remaining ordered pair is lies one Cartesian product, but is not lies in the other Cartesian product. So this 2 ordered pair only is common in both A cross B and C cross D. So we check any other ordered pair is common in A cross B also. 1 comma 5, 2 comma 2, 2 comma 3, all ordered pair is there, but all the ordered pair is not lies in C cross D. So in A cross B and C cross D, this 2 ordered pair is only common. So now I put it is equation 2. Now we check from 1 and 2. 1 means the value of LHS. What is the value of LHS? We already seen the value of LHS is also 3 comma 3 and 3 comma 5. That is only 2 ordered pair. Now we see in 2 also there will be a same number of ordered pair 3 comma 3 and 3 comma 5. So what is the conclusion? From 1 and 2 is not a proof sum. Now to check it is a true or false. So the given statement is true or false? It is, yes, true, because both have the equal number of ordered pair. They are 3 comma 3 and 3 comma 5. So we write the conclusion. From 1 and 2, LHS and RHS both have the same number of elements. Therefore, A intersection C cross B intersection D, that is the value of LHS. It should be is equal to the RHS. What is RHS? A cross B intersection of C cross D is, how to write, is proved or true? Is true, is not a proof sum. Now to check it is whether it is a true or false. So both are equal value, therefore the given statement is a true. Suppose the ordered pairs are differ. For example, I say one example. These are 3 comma 3, 3 comma 5, and LHS is also same value. Suppose one more ordered pair will added. For example, 4 comma 1 is lies in 2. How to write the conclusion? The given one is not true. So LHS is not is equal to RHS. But in this sum, LHS and RHS both have the equal same ordered pair. So we write the conclusion, the given statement is true. A is X belongs to W. You know W means the set of all whole numbers such that X is less than 2. And the set B is given X belongs to N. N means the set of all natural number such that 1 less than X less than or is equal to 4. So both the sets are not given in roster form. In previous video we already explained, suppose any one of the sets are given is not in roster form, first we convert the given set in roster form, because in roster form all elements are occurred directly. So the first step to convert the given two sets in roster form, and the set C is given 3, 5. Now to verify, A cross B union C is equal to A cross B union A cross C. So the first step to convert the given sets A and B in roster form, that is in number form. So given A. How to given A sets? In A set all the elements are X, where X is a whole number. You know every whole number start from what is the first whole number, that is 0. So whole number, and also it satisfies one condition, the value of X is less than 2. So we write a whole number, but the whole number is less than 2. So what is a possible number? The whole number is start from 0. So 0 is possible, comma 1. 1 is also possible. The next number of 1 is 2. 2 is not possible or impossible, because the value of X it should be less than 2. Okay, so you leave 2. So the set A is contains just 2 elements, they are 0 and 1. So these 2 elements is only less than 2 of whole numbers. Next we write the set B. We check what is the values of B. X belongs to N. You know very well, capital letter N indicates a set of all natural number. All the natural number is start from, the first natural number is 1, but the value of X is satisfies one condition, 1 less than X less than or is equal to 4. So the value of X it should be greater than 1 or more than 1. The next natural number is a 1 is the first natural number, the next natural number is 2, and then 3. Now we check 4 is also possible. Yes, 4 is also possible, because the value of X is less than or is equal to 4. So X value 4 is also possible. So 2, 3, 4. So these are the values of B. X belongs to N. So we write all natural number. So 2, 3, 4 all are natural number, and also X satisfies the condition, the value of X is more than 1 or less than or is equal to 4. So the possible numbers are, the big number of 1 is 2, 3, less than or is equal to symbol is given, so we write it is 4. But you see here less than 2, so less than 2, so you don't write 2. So the first step to convert the given two sets in roster form, that is in number form. The next is set C is already given in roster form, 3, 5. So in the sum, the first work to convert the given two sets in roster all this number form. Now to verify, A cross B union C is equal to A cross B union of A cross C is a verification sum. Now to check both LHS and RHS both are equal or not. In all verification, first we will be take the value of LHS. What is the LHS value? Is A cross B union C. That is, we need the Cartesian product of the set A and B union C. The set A we already find, the value of the set A is 0, 1. We have a B union C set. So the next step to find the value of union of B and C, because we need a Cartesian product of these two sets. The set A is already there, so the next step to find the union of these two set B and C. So the next step to find the union of B and C. A cross B union C. First we find union of B and C. You know the nature of union. Union means we write all the elements occur in B and C, but the repetition of element is not occur. So in B union C. So we write the elements in any manner, but it is easily to write in ascending order. That is small number to big number. In B and C, what is the smallest number of B and C? The B and C, the smallest number is 2. So first I write 2. The next number is 3, then 4, 5. So these are the values of B union C. So you write all the elements of B and C, and also repetition is not there. So 2, 3, 4, 5. The next step to find the Cartesian product of A and B union C. What is the first set? A. What are the elements of A? The elements of A is 0, 1. Cross. The next set is B union C. The value of B union C is 2, 3, 4, 5. Now to find the Cartesian product of these two sets. Simple. What is the first possible ordered pair? 0, 2. The next one is we moving the elements of the second set. We don't change the elements of the first set, we moving the elements of the second set. So first set is 0, 2. The next one is 0, 3. The next one is 0, 4. The next one is 0, 5. Now we moving the second element of the first set. Okay, 0. The next number is 1. We do the same work. So 1, 2. 1, 3. 1, 4. 1, 5. Actually it is a value of LHS, so I put it is equation 1. Now to check, the same value is also occur in the RHS. Okay, what is the RHS? That is the right hand side. The right hand side is A cross B union of A cross C. If we find the union of these two sets, first we find these two sets individually, because we need a union of these two sets. If we need a union of these two sets, first we find individual sets. What is the first set? Is A cross B. So first we find A cross B. What is the value of A? The value of A is 0, 1. Cross B. What is the values of B? Is 2, 3, 4. Now we write the Cartesian product of these two sets. What is the first possible ordered pair? 0, 2. Next one is 0, 3. Next one is 0, 4. The next possible ordered pair is, we write all the elements from 0 to 2, 0, 3, 0, 4. Next we moving. The next possible ordered pair is 1, 2. 1, 2. Next 1, 3. And the last one is 1, 4. So we write A cross B. Next we find the Cartesian product of A cross C, because we need a union of these two sets. So first we find the both the sets. So one set is fine, A cross B. The next one is to find the Cartesian product of A and C. A cross C is the values of A cross, it is a value of C, 3 comma 5. Now to find the Cartesian product of these two sets, the first possible order pair is 0 comma 3, 0 comma 3. Next one is 0 comma 5. Okay, over. We move in the second element of the first set. The second element of the first set is 1, 1 comma 3, then 1 comma 5. So it is a value of A cross C. Now we find the union of these two sets. Okay, so A cross B, union of A cross C. We already find these two sets. Now we need a union. You know the union nature. We write all elements, but any one of the element is repeated. The repeated is not allowed. Okay. We write in any manner. So A cross B, union of A cross C. Suppose sir, I interchange the ordered pair. Suppose sir, I first write 1 comma 3, 1 comma 5 sir. No problem. We write and then we change. Okay. Now we see the union of these two sets. So first I check in A cross B, what is the starting element. I write in ascending order, that is small number to big number. In the A cross B, the small number is first of all the first order pair 0 comma 2 and 0 comma 3, 0 comma 4 is there. So first I write 0 comma 2, 0 comma 3, 0 comma 4. 0 comma 2, 0 comma 3, 0 comma 4. We write the union. So the element occur either one of the set is enough. Okay. So 0 comma 2, 0 comma 3, 0 comma 4. We see the element 0 comma 3 is also lies in A cross C. Repetition of the element is not allowed, so you write only once. I write in ascending order. So first I will be taking the order pair start from 0. The next number of 0 is 1. So I will be take the ordered pair is starting from the number 1. So after 0 comma 4, the next number is 1 comma 2 and 1 comma 3, 1 comma 4. So I write all the elements in A cross B. Now I check any one of the element is missing in A cross C. We already write 0 comma 3, 0 comma 4 is lies in A cross B, 0 comma 5 is also lies in A cross C. So we write all the elements. What are the missing elements? What are the missing element in A cross C? You see 0 comma 5 is not right in this union. So now I include. Next 1 comma 3 we already write. 1 comma 5 is not lies in A cross B, so I don't write. So what are the missing ordered pair in A cross C? They are 2. So the 2 is 0 comma 5 and 1 comma 5. It's enough. We put it as equation 2. No sir, I write in ordered pair in ascending order. So no change, no problem. We write 0 comma 2, 0 comma 3, 0 comma 4. And you see one more element is start from 0. Okay, 0 comma 5. So I include the element here 0 comma 5. The next element is start from 1. So 1 comma 2, 1 comma 3, 1 comma 4, and the next one is 1 comma 5. Now I put it is equation 2. Now we see from 1 and 2 both have the equal number of ordered pair and also the same number of ordered pair. Now we see from 1. You see 1 starting element is 0 comma 2, 0 comma 3, 0 comma 4, 0 comma 5, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. How many ordered pair is there? 1, 2, 3, 4, 5, 6, 7, 8. Now we check in 2. Is also 0 comma 2, 0 comma 3, 0 comma 4, 0 comma 5, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. All the ordered pairs are same. and also equal number of ordered pair. Start from 0 comma 2, here also start from 0 comma 2, n to 1 comma 5, here also n to 1 comma 5. So from 1 and 2, what is our conclusion? From 1 and 2, LHS left hand side and right hand side both are equal. Therefore, what is the value of LHS? The value of LHS is A cross B union C. It should be is equal to RHS. What is RHS? A cross B union of A cross C is verified. The question is to verify. Here LHS and RHS both have the equal same ordered pair. Therefore, the given statement is verified. Okay, students, today we are teaching about the union of a set, intersection of a set and a set difference. How to find union, intersection and set difference. We are involving the sum involving a union and intersection. So the same kind of problem is also lies in the textbook example. I explain, elaborate in the exercise problem. You work out the example problem also. Suppose if you have doubt, you inform us. I explain all the concepts.